Alright, we're going to try to finish all these comparisons here. This is the limit comparison test. It says suppose that a of n is greater than 0 and b of n is greater than 0. And if we take the limit as n approaches infinity and we divide them, a of n over b of n, that equals some L. If that L is greater than 0, where L is a finite and positive, the two series either both converge or diverge. Alright, so I'm going to show you some examples of each here. Alright, this is harmonic, so it should diverge. Okay, you should recognize something n plus something is harmonic, but let's check it out. This is a is greater than 0 and b is greater than 0. This is harmonic. So what I'm going to do is I'm going to compare this guy to a series that looks like it, 1 over n. We know this guy diverges. Okay, so this guy, this diverges, and when we divide them, guess what? If they're all equal to 0, check it out. Here we go. We put n over n. We divide everything by n. Okay, this goes to 0, this goes to 1, this goes to a. It's 1 over a. 1 over a is greater than 0 because a was greater than 0, so therefore it diverges. So if you get this to be greater than 0, it'll diverge. Okay, this one's not used as much as the other ones. Let's do another example. This is a of n, so I'm going to make something look like that, and I'm going to say this is b of n, 2 to the n over n squared, and I'm going to divide them. Okay, when I divide them, I want things to go out. So I get n cubed up top, the two n's will cancel. Okay, because remember, I'm going to put this like this. Alright, and those are going to cancel, and that's how I got that. Now I do my limit, and I get n cubed. Remember, it's the coefficients of the power, so it's 1/4. Okay, this is equals to 1/4, so it diverges. Remember, anything greater than 0 will diverge. Right here, anything greater than 0 diverges. Okay, here's one that will converge. Check this guy out. I'm going to set, this is, remember, n to the 1/2. This is n squared plus 1. Alright, so now I'm going to do 3 halves. You might say, why 3 halves? Because I want to get the power up top and the power on the bottom be the same, which I do here, n squared over n squared. So when I take that limit, I get 1. That converges. Okay, and the limit comparison test says, hold on, we have to get something greater than 0 to even have a shot at converging. Well, I know that this is a p-series that converges. Okay, so if I got something that's greater than 0 here, so therefore it'll match and it will converge. Just to recap, if you look back here, I got one here that diverged. Okay, this guy diverges. You might have even saw that in a homework problem with the 2 to the n. Okay, so this one diverges, so when I got something that's greater than 0, it follows b of n. Look at the one before it, just to show you. I've got something that diverges here. I get an answer that's greater than 0, whatever a is here, because a is non-zero. It's greater than 0. So this one will diverge and follow that. So basically, you're choosing something, and then you have to know it's whether it diverges, b of n, whether it diverges or converges. If you know that, then when you go and divide them, if you get something that's greater than 0, it'll follow to whatever b of n is. Okay. All right. Let's see. Do I have any others? We just did that one, and there is some homework going on. I'm good. We can play in class. I want to do another one, though. All right, here's a theorem. The a of n is greater than 0. This is a, I'm shooting a video, by the way. All right, so this is alternating series, and the alternating series, like I said, is this one is all the odd numbered ones will be negative, and this is all the even ones will be negative. And they converge if we just take the limit and it equals 0. That's it. We need it equal to 0. So let's show what happens. If I have an alternating series with this one, okay, I think it's clear that n plus 1 is less than or equal to 1 over n. So I don't know if I need that, but I'm going to tell you right now that what I'm going to do is forget about the alternation and just take the limit. That guy's 0. So therefore, this guy converges. Okay? So we kind of forget about the alternation, and we just take the limit. Look at this one. This guy alternates, okay? And we have n plus 2 over n plus 1. We have to check this. We have to check this. So it works because we need it to be, one has to be less than the other. So what we do is we take the limit, take off this, and just go. It's bad. This equals 1. That's bad, therefore it diverges. Okay? What did I say in the beginning? I said it must equal 0. If it equals anything other than 0, it's bad. Look at this one. Negative 1 over k, negative 1 to the k, k plus 1. Okay? Let's just go ahead and do it. Make sure you check to see if that's the case. Okay? Because we want one more here would be k plus 2. Alright? So now this guy converges. Alright? As k goes to infinity. Alright? This guy will converge. Let's continue. Absolute and conditional convergence. If the series converges, then we say it's absolute convergence. So if we can do the absolute value of the series and get rid of the negative, and that's kind of what the alternating series does, we say it's absolute conversion. But if the regular series converges but the absolute value diverges, then it's conditional. Let me show you a couple of examples. This craziness, okay? If I take the absolute value, we can get rid of the negative 1. By the way, that's what I think it was for that cosine one. All right, if you remember that cosine one we did in class, I think it was something like that. All right, well, if we do the absolute value, it takes away that, and we have 1 over 3n. This is a converging geometric series, where r is 1/3, okay? All right, so this is absolutely convergent when I try the absolute value. This one, when I try the absolute value, I just get ln of 2, ln of 3. This is harmonic. It diverges. Okay. However, if you just look at this guy by alternating series test, okay, alternating series test, it converges. So we call that conditional. Here's another one. This is a diverging p-series. Okay, because p is 1/2. Has to be greater than 1. So here we go. We check it out. This guy diverges, but then taking away the negative 1 or the alternation, we get this guy converges. So this is conditional. There's some homework there. We'll do that in class, so we'll get them all together. One more is the ratio test. All right, the last one is the ratio test, and that means it converges absolutely if you do it by the absolute value. Notice n plus 1 over n. So we have to add 1 to it, put it over n, and it has to be less than 1. This is most important, that it's less than 1. Okay? Has to be less than 1. It diverges if it's greater than 1 or infinity. Okay? So that diverges. Actually, I'll do this in green. It diverges. Inconclusive if it equals 1. So if it equals 1, we're in trouble. We can't use this test. That's what it means. So let's try it. Here's one. 2 to the n over n factorial. What I'm going to do is I'm going to take the limit as n goes to infinity, and I'm going to do 2 to the n plus 1 over n plus 1 factorial. Okay? All over 2 to the n factorial. Well, I'm going to make that nice, and I'm going to get 2 to the n plus 1 all over n plus 1 factorial times n factorial 2 to the n. And it always kind of works like this. If this is 2 to the 5th and 2 to the 4th, what happens is you're just left with 2. Okay? And then this is n factorial, like 5 factorial, this is 6 factorial. So you're just left with n plus 1. I go ahead and send this guy to infinity, and I get something close to 0. I get 0. Because this is getting infinitely large, I get 0. What does this say? Ooh, converges absolutely if that happens. So guess what? This can converge absolutely. Or absolute convergence, okay? Because it equals 0. let's do another example. Let's do this one. All right, I'm going to multiply this by 3 to the n plus 1, okay, because it's like dividing it, all right? And then this is going to be n plus 1 squared, and this is 2n plus 2. So, 3 to the n and 3 to the n plus 1, well, that's just going to be 3 up top, okay? N squared, like 5 squared and 6 squared, we can't do anything with it, so that's just n squared on the bottom. Is going to be n squared plus 2n plus 1. And let's see if we can screw with this. We got 2 to the n plus 1. That's like, let's say n is 5. So that'd be 2 to the 6, 2 to the 7, so there's just a 2 on the bottom. And I'll distribute it nice. Watch how I distribute. Nice. Now, I'm going to apply the limit. Now we'll apply the limit. Remember, this limit as n goes to infinity. This is our ratio test. Important. This and this is just the coefficients. I get 3 halves. What did it say about going over 1? It said if it's greater than 1, it diverges. So guess what? This guy diverges. All right? This is one for these two are for you to try. Okay? You got this one and that one to try for homework. I definitely want you to do those two. And that'll do it. I think we have maybe one more concept that I'm not going to do a video on. So enjoy. This was one of your last ones. We maybe have one more. All right. Ratio test. We looked at all these tests. Ratio test. We looked at limit comparison. The only thing we have to look at, I guess, is direct comparison, which is okay. But look, the ratio test is probably the most important, and alternating series. All right, take it easy.